Greetings. So one of the questions that probably should come to mind is why in the world would the Babylonians want to take and use base 60? It seems that that would be just an arbitrarily hard number to use. And let's think about it for a minute. With addition and subtraction, no problem. We have a place value system, so I can really look at it and say to myself, all right, we just line things up in the appropriate place values and add or subtract normally. And that's no problem. The bigger problem might be with how would you multiply? And their multiplication would be a lot like ours in the sense that you would simply line things up and you would just have to keep track. You're going to have a very big multiplication table, or you're going to have some concepts around the distributive property to help you do the problem a little in a simpler fashion. Either way, it's not really that bad. But the beauty of the system comes out in the fact they did use base 60. Now let's think about why. And I'm going to show you some reasons why. 60 is a beautiful number in the fact that I'm going to begin listing the divisors of 60. We'll rule 1 out because that's boring. But 2, 3, does 4 go into 60? I do believe so. 5, 6, 7's not going to make it, nor is 8, nor is 9. However, 10. Now at this point I'm going to start cheating. I know it's 2 times some amount. Well, 2 times 30 gets me to 60. 3 times 3 times 20. 4 times 15, 5 times what? 12, and 6 times 10. So there are all of the numbers that divide 60. Now, why would this be so interesting? Well, we have a clay tablet that points out why that was what they were after. Because they know how to multiply. And if you know how to multiply, you can divide. Let's look at something for a minute. Let's go into the benefit of our numeration system, and suppose I want to have 35 divided by 5. I may not know how to do division, but I know the answer to this problem, whatever it may be, would be the same as if I said 35 times 1/5. I can multiply by the reciprocal. You don't ever think of doing this unless you do it in the other direction. If I were to say 8 divided by 2/3, in grade school you learned change the division symbol to multiplication, reciprocate the divisor, and tickety-boo, you're off to the races. Well, that is true, but you can also do that with whole numbers and multiply by 1/5. So what the Babylonians did was they took this idea of divisors and said, we're going to use this to our benefit. And we're going to have 2 over 60. We can represent 3 over 60. We can represent 4 over 60, 5 over 60, and etc. And by doing this, they're going to be able to represent amounts that we can deal with. And so what's going to happen is, if I were to look at this, I would say 0 ones. I'm going to use a semicolon to separate the ones from the decimals place. And in the 60s place, 60ths, I would have 2. Here I would have, if I were doing this, I have 0 ones. And I'm now going to have a 3 here. And so I can all of a sudden rewrite all of these amounts, let's say 30 over 60, which we would call 1/2, would be expressed in the Babylonian system as being 30 parts out of 60. And by the way, in Babylonian, to keep this to understand it's 30 and not something else, I'm going to separate place values by commas. So I would have 0 back here to really point out to you. I wouldn't normally do this, but I'm showing you I don't have anything in the 60 to the -2 place. Remember, this is 60 to the negative 1. So as that happens, we have these multiplication of reciprocals. And so that is actually how the Babylonians would deal with division, would not be to think about it as a division problem, but multiply by a number's reciprocal. The Babylonians also knew something else that was interesting. Certain multiplications render 1. Now think about that. If you're going to multiply 20 times a number and you want to get to 1, what do you have to use? 1 over 20. So basically these Babylonians have come up with this concept of, okay, we're going to use the idea of I know a number times its reciprocal is 1. I can build lots of reciprocals easily because I have 60 as my base, not like 10 where you get 2 and 5 and that's it. And I can do multiplication pretty efficiently as long as I have a lot of information written down. So the Babylonians actually had this pretty well worked out. They just were trying to do things, and with a lack of ability to basically go beyond because, well, think about it. They're answering the questions they need to answer. And this would work, and they're not really under any pressure to try to do anything differently. There's no reason why we don't use base 60 or base 12. Mathematicians for over 100 years have said if we really wanted to do things arithmetic-wise very smartly, we would switch to base 12. Now, can you imagine going to school and trying to learn base 12? It wouldn't be that hard. It'd be just like learning base 10 with 2 more symbols. We can make them up, whatever we need them to be. The idea is the concept of the base isn't going to play with you. Think about the process. The process tells me how to do something, whether I'm in base 10, 12, or 60. Remember, computers use base 2, and they seem to get on just fine. I hope this helps.